Hello, everyone, and welcome to today's webinar. This is Abhishek. I am the IoT market analyst and co-member of the business development team at Factorna. So, thank you for joining the webinar. And for those who want to make sure you're in the right place, this is going to be a 1 hour webinar on Industry 4.0 remote equipment condition monitoring. So, before we begin, let me give you a brief introduction about Factorna. So, we are the cognitive IoT company specialized in industrial automation solution. We provide IoT-based solutions to small, medium, and large enterprises. We provide industrial IoT platform called Fogwing, which is the next generation no-code IIoT platform. Along with this platform, we also provide automation solution as SaaS model. Our SaaS-based IoT solutions are Fogwing Eco, Fogwing Agro, and Fogwing S Factory. So Fogwing Eco is our environment monitoring solution, and Fogwing Agro is the smart agriculture solution, and S Factory is our upcoming manufacturing intelligence solution. So this webinar will be presented by Mr. Hariharan Ganesh, the founder and chief architect of Factorna. And Hari, over to you.
Thank you, Abhishek. Hello, everyone. Good morning, good afternoon, good evening, wherever you are watching this video. So, as we talked about the remote equipment condition monitoring. So, in today's situation, we are in the middle of challenging condition across the world as we are limited to travel. We are limited to giving access to our employee workers as there are a lot of restrictions here and there, and we may not able to move as we frequently do that as we have done last year. This year being a pandemic situation, we have a lot of restrictions from the human health standpoint and personal accessibility standpoint, resource accessibility standpoint, availability standpoint, as many of them are on in a different conditional situations, personal situations. So it is not as we practice so far of going to the remote missions or anywhere we have the missions, right? As a manufacturer or as utility companies, we have missions across different places. We might travel very frequently in the past, so now it's not possible. So with this condition, we are in a business challenge that we may not able to serve the needs quickly. And because of lack of access to the machineries, we are leading into business loss, or maybe a limitation on the productivity and the manufacturing goods and other things, right? So these are all challenges we are going through. But to precise on the high level challenge or key challenges that today the manufacturer or utility company or any kind of company where they are relying on the machineries for their productivity, they have to handle the travel restrictions and the skill availability or resource availability due to health challenges across the world. We may not have people available at different location as we got last year or previous year how this business was operating. And now due to all this restriction, the service cost has been increased tremendously as the risk has been considered by many vendors. So the cost of service or third-party services cost has been shooted up heavily. Now, because of this lack of access to the machineries, we also facing, we don't know whether when the machine is, how the machine is operating, whether the machine is still operating, or is there any productivity, is there any challenge at the machine level, is there any equipment failure in the machine level. We don't have that visibility because we don't have access to the machineries. And that leads into a lot of business uncertainty and continuity problems. Now, this clear challenge that we may not able to access the machineries as we do. So now what is it we should do now? We need something like a remote, right? We have a remote for our TV, we have a remote for our car, but we don't have a remote for our own machineries. And that's a very important piece of that. We need to start looking at that. And Industry 4.0 itself is talking about how to create a connected environment for the machineries. Now, remote operation or remote monitoring is the key solution for this challenge, right? But how do we get the remote? What is it remote monitoring? What is mean by remote operations? We never practiced this before. So now, how do we make that mission accessible? The mission can be accessible only if the mission has equipped with connectivity, the internet connection, right? The mission should have a connectivity. But these are all traditional missions, legacy missions. machines that are remote places, they operate by themselves with automated controls, are programmed in the remote level, and they are being running there. So now we need to make them connected to the internet. Then only we can access that equipments or machines remotely. Second, to understand mission performance or mission running time or mission problems, right? We need to have a sensing capability in the mission itself. The sensing capability in the sense like, what is happening in the mission, how the mission is operating, when it is starting, when it is stopping, and how things are happening in the mission level. We have to have something to understand that mission and then give that information to us through internet. Now, once we have those informations, we need that information for longer term analysis, right? So we need to have those information stored somewhere, and we have to look at the history of the information. It's like a ledger, it's like a logger, right? So we need to have that information for the logging purpose, and then later we can look at that how things are happening. So we need that kind of data storage in a secure environment, right? Or the log registry in secure environment. Then we understand this history of this data or history of the information that is coming from that missions, to understand what kind of a pattern is happening in the mission level, what kind of challenges it is going through, is there any abnormality in the mission level, in mission operations. So we need to start understanding that it is not just a logging, understanding that. That's the purpose of the remote monitoring, right? Then based on that, we need to give a control. Oh, can you turn off this motor, can you turn on this particular component, or can you turn off this fan or turn on this fan? So all this remote control, remote monitoring or remote managing has to happen, right? The control has to go there. So all of them are required in today's condition to still continue the business the way that we have been operating, and more efficiently, in fact, and then continue to generate the business sustainability. So that's a kind of a solution that we need at this condition in today's world. Now, how do we do that? And this is where the industrial internet of industrial IoT or industrial internet of things is coming into picture, right? The IoT, what is IoT means? IoT is basically making anything to connect it with the internet, anything controlled connected with the internet. So enabling any device or equipments to connect to the internet and making it accessible is the way that this solution works. Now, industrial IoT is kind of a specialized solution within the IoT space itself, where the mission gives specific functions to handle the machineries or manufacturing scenarios or industrial scenarios, like device management. How do we manage the equipments? How do we control the connectivity of the equipments? How to connect with that? How to extract the data? How to understand that information from that equipment? So all those components are device management capabilities, storage capability, the streaming capabilities, streaming in the sense like how the data collection is happening from the machines, triggering automatic alerts when the machine is facing a challenge, like in terms of the machine operation or motor operation, or any sudden subsequent noise being generated because of lack of some lubricants, or it may be due to some other faulty machine mechanical problem, right? So we need alert mechanism. So that part of the industrial IoT solution, triggering a command to control the machineries, right? That's part of the solution itself. So on top of that, having a visible view of what is happening in the machineries. So all such functions, features are encompassed within the space of industrial IoT solutions. And it could be a cloud-based product, it could be a different kind of a product, but more important is the functionally how it is helping us to connect to the machineries. Now, what is the value of this? How this can be, what is the value of this? How we can connect to that? So we have to have the set of connectivity devices, because the equipments or the machineries are traditional legacy machineries that are not equipped with connectivity. They are not equipped with the internet connection. So we need to enable the machines to connect to the internet. So, right, we need a connectivity there. So that's where, there are a set of components we need to attach with the machineries, such as IoT gateways, which are like your typical internet modems. So they connected with your machineries to make the machine to communicate to the internet. Then we need to have a wireless communication. If it is a remote mission, remote equipment, we need to understand how that internet connectivity itself is happening, right? So it's very typical, like, you can use a cellular connectivity, or you can use other network protocol, the open network protocol, wireless network protocols available, which can be used, such as LoRa or Sigfox or NB-IoT, other things. So all of them, we can use it to make that mission to connect to the internet. So there is need of wireless connectivity and related status, right? And third thing is the security of the channel. How do we secure it? We don't want somebody to get access to our machineries, right? So we need to secure the channel of communication, so and securely receive the data. Controlling the machine, by triggering a command. We need a switch in our control, right? We need a switch in the way of like how we operate a TV, right? We have a remote to control the TV. Say, or we today, we can control our car with our mobile phone itself, right? So how do we control that machineries from the remote to that? Or what if the machine is unable to connect to the internet due to some connectivity problem? So we need to have all the data to be stored. So there is edge computing related capabilities are helping there. So all of them is provided as part of the industrial IoT. So the role of industrial IoT is to make the equipment connected to the internet, and then gather the information, analyze the information, and trigger the alerts. This is the core functions that provided by the industrial Internet of Things. But the very fundamental things, to understand here is how I can connect to my missions, right? This itself is a question. It's $1 million question right now. Since it's a complex part to understand, let's take three type of examples. Very fundamental thing is every equipment mission is different. Every equipment mission is different. Every equipment have a different language or different data that can produce it. So we need to have the right way of capturing that information. But it also depends on what you want to capture. If you want to capture just the running time of the mission, that's one way of looking at the basic information gathering. If you want to understand how my machine is operating, is there any mechanical or technical problem in that, is there anything going on in my machine's health condition, so then that means we need to add little more sensing power to the equipment to gather those informations, right? And then, oh, I need to understand what is the productivity of my machine, how much it has been producing, right? That I want to understand, that we need to have little more sensing. So it's level of sensing that we want to add it. So it depends upon what you want to do. That you want to simply understand the runtime, or you want to understand the runtime and the problem that machine is it's happening in the machine, or you want to understand the productivity of the machine. So to take it up, we put the three different type of equipments here for better understanding. Let's start with the simple motor. The simple motor can run there, right? If you want to understand only the runtime of the motor, I want to know when the machine motor is running, when the machine motor is shut down. I want to know the runtime of that. It's simply you can understand from the flow of current, how much the current consumption, when the flow of the current within the motor, that motor is operating there. It's taking current to operate, and when it shut down, it is not taking current, so it's become zero. So we can simply monitor the operating running time of the motor with simple current flow itself. So if the motor doesn't have the connectivity, doesn't have the inbuilt sensing capability, then we need to add a sensor into that. We need to have an external sensor or retrofit sensors that can measure the current flow of that machine, right? But now your expectation is that, okay, I understand the runtime, but I also want to understand the motor condition of that. Means, is it properly running? Is there any mechanical, technical problem is happening there? Then we need to add the vibration sensor if it is a motor. If it is a motor, we need to add a vibration sensor to understand, is there any vibration changes happening? When mechanical problem happening in the motor, there is always a vibration created by that. The frequency of the vibration, we need to capture it. So we need to add a vibration sensor if there is no inbuilt sensor available within the motor. The modern motors are coming with connected or inbuilt sensor capabilities, but the traditional legacy motors, which are installed 10 years back, 5 years back, or 20 years back, doesn't have this kind of a capability. So we need to add the sensors to that. Then the third one is the speed of that, to understand the productivity, how much my motor is producing, right? The speed of the motor. So that is a third level component, which also, again, if it is no inbuilt sensing capability, then we need to add a retrofit sensors to collect that. So this is only in the motor level, right? If you take the same information, if you put it in the air compressor, there is the other set of data, right? We need to scan. Of course, the current flow is can be understand, how much the compressor is running, and then the second level, the vibration can understand how much the compressor is creating vibrations, and the upper level of the vibration to detect it if there is any mechanical or technical problem. And then you go to the next level where you can understand how much air pressure is produced by this. So this is a productivity information. So for the air compressor, we need a pressure sensing capability, but for the motor, we need a rotor speed or speed understanding capacity to understand the productivity of that. So it varies from mission to mission, what type of information that we want to capture, and what type of data that how the machine is equipped, what the purpose of the machine, that the sensing capability is sensing or sensor need is different. Now, if you take to the machines that are programmed machines like a CNC machines, they're all equipped with the program and they're all running on based on the programming capability, right? So it's already inbuilt with all the mechanism to sensing all those informations. Now, those such systems, if it is a legacy systems, we can use their different connecting protocols like MT Connect to get the data, or if there is a inbuilt interface provided by them like a serial port or anything, then we can read the data from them. But here we can read a lot more information, right? If you look at that, the CNC machines, if you put connected to the CNC machine, we can understand the cycle time of the machine, which is a more on running time. The alarms, the number of times the machine getting into the faulty conditions, the alarms, we can receive it. The downtime of the machines, we can understand that. So runtime, downtime, alarm, even the productivity of the machine, we can get it as a data itself. So it produces the data directly for us instead of understanding the sensing informations. So it's clearly a different approach has to be taken depending upon the equipment and depending upon the life of the equipment or the lifetime of the equipment. So we need to take a different approach. This is where the sensors and actuators are playing a role. And on top of that, you want to store the information locally for some time before you move it to your system, or you want to instantly send it to your systems, or instantly you want to see that. It's all depends upon whether you want to have the data logging capability or not, and things like that. But fundamentally, we need a different sensor for different needs, and we need a different type of equipments, need a different type of interfacing model to get the data out of that. Now, to holistically put together, right? Now we saw that we need a sensors. Now we take two examples. One is the inbuilt CNC machines, which can send PLC SCADA data, or it may be MT Connect, using which we can understand the signals of the mills and get the data to the IoT gateway. So here they're playing the role of IoT gateway, to send the data wirelessly to the remote storage environment, which could be your cloud storage environment or the IoT platform. And on the retrofit sensors, sensing the sensors information and send it to them. So there is a clear distinction. One, the PLC SCADA system or the mill systems can produce the direct output. So the data can be communicated to the cloud and then visually see that in the visual trend analysis tool or any other dashboards. But in the sensing retrofit sensors, which generates only the sensing information, and that information has to be managed, analyzed, and then come up with the trending analysis. So based on the trend, it is not a direct data that is coming and saying, hey, your machine is having a bearing problem, or your machine has the machine is stopped now due to mechanical problem. It doesn't say that in the sensor world, but we need to analyze that in the cloud or in the IoT platform to create a trend. So technically, we need a IoT gateway to implement. We need an IoT platform, and we need a visual tool to understand the mission performance or mission monitoring, right? Now, only if you monitor the mission, then only you will know that what is happening in the mission, how long the mission is running, how efficiently it is running remotely. But looking at the data, right, there are two types of data that we are holistically looking at. Because when you see that, oh, how I will see that in the visual standpoint, right? Now this is how you can see that in the visual. Different tools can produce a different one, but you can see that there is a clear two type of comparison here. One is the performance data, another one is the utilization of the data, right? One is the performance data. Performance data also means that the high and low of end of that, right? When the machine has a lower vibration and but continuous production, that means the machine is in high performance. When the machine has a continuous production but higher noise, that the machine has some kind of a performance problem, right? So all of them we can capture it in the performance. So you can see that one of the trend graph is showing the peak time of that, where the machine went through some kind of a performance challenges, or the vibration data, or the high performance in time, right? High performance time. The bottom layer, where you can see the comparison of two machines. If you are not sure, oh, is there any problem in my mission, right? Mission 1 versus mission 2. If they are identical mission, we can compare the two missions to come up with, which mission is taking higher runtime, higher, performance, higher issues there, or it may be a trend comparison of that, right? May comparing the runtime versus issues between the missionaries to understand which one is doing better, or which one is comparable, right? So this kind of a comparison metrics also we can do it in the data. So once you have the data, then we can start putting the analysis, and we can come up with the understanding of how this data can be interpreted to come up with a meaningful, thoughtful idea about how my machine is working. Only if you understand how your machine is running, how your machine is performing, then only you can do some actions on that. You to prevent your mission stoppage, or downtime. You can do some kind of a maintenance activities or some other activities, right? Or you can shut down the machines before even it breaks down, right? You can shut down the machines when it's going on high vibration, because there is some mechanical problem is happening. If the vibration is above, then I want to shut down the machine, which is remotely possible, automatically possible in the IoT world, with the help of the sensors and the gateway and the platform altogether. Now we will see that in today we are going to demonstrate this and how this can be measured and analyzed in our tool. So data analytics, right, is a solution or the way that we need to understand the data that's generated by the equipments. So IoT data analytics is a way to analyze the data to understand how the data produced by the machines. Now it is part of our, so we provide the IoT Analytics Studio, which helps to monitor the machine and understand the trend of the machine utilization, comparison, and also any of the challenges that machine is facing, right? Either you want to measure the runtime, or you want to measure the performance of the data, or you want to measure the productivity of the information. All of them can be monitored, visually see that, analyze and see that, and also triggering alerts in there is issues. So all of them as part of our analytical capability are a part of the product feature that we offer to help the remote equipment monitoring make it easier, right? And let me take instead of more time, we want to show you a demo of how this could be possible, and we want to show it. And by the way, the Analytics Studio is an add-on solution to our existing IoT platform itself. So we not only providing the device management capability, but Analytics Studio is also part of our offering for our customers to leverage it. So it's bundled together as a complementary service to our industrial customers. Before I go here, let me take you to the okay. So if you are first time you are seeing our industrial IoT platform, here it is. This is a Fogwing industrial IoT platform, which has been created explicitly for the industrial use cases, where we wanted to understand, we want to provide the IoT platform capability for the small and medium businesses to connect their machines, or measuring their IoT scenarios use case, or build their own IoT solutions, things like that. So now you are seeing the dashboard. Let me take a quick walkthrough on this. If you are first time seeing this, then I will move on to the how we can monitor the data. First thing, we talked about the connecting to the device, right? So connecting to your machineries. To connect to your machineries, we created a network, right? We create a network between your machine and the visual part of this application. Let's assume this is the application. So between the equipment or device or the machine to the to the application, we need to create a network. So we call this as an edge network, where you can define it. Okay, I need to deploy a device. I need to deploy a gateway or wireless capability to my missions. So you go and create a you go to the edge page and you create connectivity with your equipment by using gateway. So you need to have an IoT gateway, which is a physical hardware that you need to connect with your missions. The physical hardware will comes with the inbuilt sensors, or maybe it's external sensors that will be fixed in your equipment. So the sensors collect the data and give it to the modem. It's like a modem, via internet modem, that can create data and send it to the application environment in this cloud infrastructure. So you need to declare your edge, and you need to declare your sensors, right? So if you go here, when you fill this information, then you will go to that, you will see the sensors. Let me show you one data. Now this asset one, right? So this asset one, you can see here, we have created a device in the factory environment, which is monitoring a specific device or the equipment, or you call it as asset. Then you go to the attributes where you declare your sensors that you have fixed on that particular on the particular mission, so that you directly take it and understand this sensing information or sensor information or the data produced by that. Even if it is a CNC machine, if it is producing the data, you can still declare what kind of data it is producing on the attribute level, so that you can see this data in the analytics studio clearly. So you need to declare the edge, step one. You need to give access to your mission. So this is step two. Now you can show you here, the access information. We use a protocol. We suggest and use a protocol called MQTT. It's an industry standard secure connection protocol. Send the receive the data in the cloud from your mission. So you need to configure this MQTT configuration in your device. If you purchase a device from us, we will pre-configure this configuration for you. So you don't need to worry about how device configuration. I need to do that. I don't know that how to do that. So we help you to solve that problem, or we give you the device that are pre-configured with our platform. So you don't need to think about that. You can just go and connect the sensors, and then you can start seeing your data in the cloud. And if you are first time you are doing that, you don't need to have a device to communicate to the cloud or to this platform. You can use our simulator programs, which is an inbuilt kind of a testing tool, which you can use it to send some data. So let me show you on how we can do that, right? And how we are going to communicate to that. Then the last part is a command part. Command is more like, you wanted to send the on condition, off condition, or you want to send some kind of a switching, on and off switching to your missions. Then you can configure your command. The command can be executed by automatically based on the data. Hey, my vibration is going beyond this limit. Can you shut down the motor? Or my room temperature is going, or my factory temperature is going beyond this limit. Can you turn on the exhaust fan? So we can configure anything here as a command that can be triggered to your device or your equipment to control your equipment. So this is where your controlling mechanism is here. So as a platform, we provide you not only the data collection, we also, you can also trigger the command to shut down, start, and stop your device, equipment, or anything that you want to control it automatically through the platform. Now, if you want to set up a set of alerts, like when a vibration is going beyond this limit, I want to trigger a alert. I want to receive the notification. I want to alert, notified that my mission is going here. So you can go here. You can set up a alert. You can set the variable which level you want to set it up. If you see this use case where liquid level is lesser than 10, we are triggering a motor on, right? Or you can even set it up in another case. If you go, I will show you another case. So if this case, send a command again, right? So we can set up any type of alert to show the data or the alert, receive the alert. Now the storage is our inbuilt storage capability. We provide all the data storage capability inbuilt with our platform. So you can go and all the data is logged here. So you can have a history of your data stored here. You can go and look at your data, right? So you can look at your data. Oh, this is my data is coming here. But remember, this is more like a technical terms, like a JSON files is coming. Should be coming from your device and stored as a JSON file. But if you're not familiar with the technical terms, you still can use this. You can see this data in our Analytics Studio in a different way. But here it is stored as a technical storage data, right? So it is stored there. So you can also still see this. Now, analytics is a different capability that I will show you there. If you look at that, your device configuration, your data rules, your storage, all are 5 simple steps here to create it. Now, if you want to send a data, right? If you want to send the data to your environment or your device, you don't want to invest time in building that first and then testing it. You can do it by simulator, right? As I talked about. The simulator is a fantastic feature here where you can pick and choose which device that you want to send the alert. Let me take a device 4. There is a sample data provided, but you can change this the way that you want. You just take a sample data here and then just simulate it, and it just published the message here. So now if you go here in this data storage, you can see that fourth one, right? You can immediately see the data here coming. Instantly, it's all live streaming, so the data is coming instantly to to the platform. The moment the exact moment the device has been triggered the data, that same moment the data will be available here. So you don't see any lagness here in the platform. And then you can see the data is published here. Very simple, right? So you don't need to write a program to connect to that. You can simulate it before you write a program, so you understand how things are working in the platform itself. Now let's go to that. From the industry equipment monitoring standpoint, today we are going to focus more on the data, right? Now I have already simulated a lot of data here for this demo purpose, but if you are first time doing that, you may not see this much data. So you need to wait for your data to see that in Analytics Studio. But I have simulated a lot of data to demonstrate how the data will look like. Now, when you click on the analytics, data analytics, it will be opening a new window, which is a completely different UI. So this is our Analytics Studio, which already pre-configured for this particular user. But when you first time logging into this Analytics Studio, you will not see any of the car or data displaying here. It's all customizable. So when you see the first time, you have to go here, click on the settings, and you pick and choose the options available. You want to see the critical alert, you want to see the number of connected devices, or you want to see a particular device data. You can configure what you want to see that in the dashboard. So this particular scenario, if you see the card one, I have created, I have right now showing here connected devices. If you go to the card 2, let me take a card 2. Right now it's showing a critical alerts. So instead of that, I want to show the number of unconnected devices. I can change it there. Instantly it will show you unconnected devices. Or I wanted to show like today's warning data, not a critical data, warning data, right? So I can click save that, and then automatically it shows a warning data, right? No warning data today. But if I want to see the particular device data here, because which is very critical for me to understand, hey, I want to see a particular device data. Let's take device 1 or the engine 1. I want to see the noise level of the engine, right? So you can see here. Yeah. So you see the noise data here. So you can pick and choose what you want to see that in the card, and accordingly the data will be stored. And then every time you log into your dashboard, you can do that. So the user can pick and choose what they want to see that. Let me bring it back to the critical alert for the day. Okay, so now the third one card is kind of a trend card, last 7 days card. 7 days, you want to see the short-term view of your particular data, any particular device data. So right now I have set it up as a warning data, but you can set it up as any data there. And similarly, you can see a particular mission trending things, and you see the data that coming up, last few data that coming up in a day. And you can also see a map view of this, where you can, if you don't want to see the map view, you can still go there and change it to the table view. That gives you the device information in the table view. You can see that how many devices are connected now, right? And you can go back here and then go map it to Google Map, and then it just shows the map view for you. So you can pick and choose the dashboard. So this is where the equipment monitoring is coming into picture, where you want to see a particular mission. Let's take, you have 10 missions you want to monitor, and you see one particular mission is always troublesome, and you want to have a easy access to that mission, and you want to always keep eye on that mission, right? You can see that data here. You can set it up as a longer visibility, or you want a shorter visibility, or you want instant information about that mission performance. You can set it up here, or you want a traditional trend of information, overall traditional trend, you can set it up. So whatever you want to see, that whatever your priority, you set it up as part of the dashboard here. Now this is an easy and quick way for you to understand what is happening in my missions quickly, right? Now this is a dashboard. Now the next function that you can see here is, I want to know the trend of this, right? Now you want to know different equipment. Let's take, I have 4 equipments or missionaries that we have connected here, and where I have configured the 4 missionaries, which I have shown you here in this edge level. You can see that there are 4 assets are declared here. The 4 assets are displaying here. So what you configure here is what you will get here in the devices. So you configured the 4 assets monitoring, and you are measuring this 4 asset data or equipment data. Then you are seeing that 4 assets here. Now you choose the asset 1. Let's take an asset 1. Okay. So these are the 8 parameters I'm getting there. That means 8 sensors I have installed on the mission to measure your data. So I see end to end of that, from the simple running time, runtime of the operation, running time of the mission, to all the way to the productivity. I can measure it with the 8 or 9 sensors, depends upon the mission. So now you can see all the current data that is showing. The last record, it's showing here. When you publish when the messages get published here in the platform, automatically that message is pulled and showing here. So you can go and see, okay, this is my current one. If you look at that, the latest data, then I see that, oh, there is a the power consumption is higher, so that means the machine is still running. If it is completely zero, that machine is not running, it's shut down. The vibration is really higher. Oh, I see a lot of vibration there. That may be because of my water pressure is high. There is a pumping, water is flowing, so there is a high water pressure. That's why the vibration level is. So that means it's taking its necessary power to run the pump the water. That triggers a vibration. So all of them are showing that this machine is operating. Let's take the pressure is lower. The water pressure is lower, but the vibration is higher. That indicates that, hey, it's not producing the output that required, but the vibration level is higher. That means it is a problem. So you need to understand the data trends before you conclude this, right? So you need to know that what is a normal vibration level of my motor? What is the abnormal vibration level of my motor? So what is my normal level? Like periodically, how normally if it is running, this is my vibration is beyond that limit. So you can set those kind of normal, beyond normal alerts, and you can trigger those alerts also in the platform itself, in the studio itself. Now you see the water level. Similarly, you can see all different parameters, but I want to see a history of this. I want to go a little more detail. I want to see the history of this particular power consumption, right? Or the frequency. Let's take in a frequency, because that's a vibration frequency. So I want to understand my machine performance. Now you see here, we are going drilling down into the vibration level of that particular device, where you can see the device information in the beginning, but you also see that, the last data that coming from the device or the machine. And also you can see here, the last 7 days of history of the data, right? You can see here, there is a trend going up and down here, again, going up and down here. Last 24 hours, I see a lot of vibration is triggered. Oh, I see that, there is a vibration here heavily. So let me close that one, maximum vibration. So now I remove the minimum max average. I want to see the maximum vibration created by this particular machine. So now you can see here at 15 hours, this machine has created a maximum vibration of 210. That means at this current time, right, it is sending 210. Previously it was 135. The normal one is 65. So this is a normal view. It may be some triggering, some issues there at the point of 5 hours, the UTC time. Maybe it is, now it's creating a lot of noise. So there is a trend happening here. So you can watch the trend of this noise over the period. Since I have lack of data, I'm not showing you full detail. But if you have a continuous data coming in, this graph will show you the entire trend for the last 24 hours. Not only the 24 hours, last 12 months, I can see the data, right? You can see that, in the month of September, I got a lot of vibration. And then again, now it's going to the peak of that. November, I see that plenty of vibration is happening. That means usually my machine doesn't generate that much vibration. Nowadays, it's creating more vibration. That means there is a need for some maintenance activity in the machine, right? And we can see that. Or if it is a flattened curve, right? So you see that, there is a drop here. It could be a shutdown, periodic shutdown, or it could be a mission shutdown issues, downtime issues. So anything, you wanted to capture it, you can capture it. Last 30 days data also, you can capture it here. You can see that, minimum and average, where, you can see that minimum of, vibration is on the 10th of October. You can see that there is a minimum vibration of 15 and average vibration is on 31, which is correct, perfectly fine. But suddenly it sees that in 38 and now it's 75. Oh my God, this is showing some big vibration in the last 30 days. So you can understand the trend of this and time series of this data. Also, you want to check your particular data, you can check here as well. You have a history of data, you can pull the data out, and then you can see the data actually on how this trend is happening. Now, okay, this is about vibration. What about my power consumption, right? My motor power consumption. Oh, I can go and switch here. You don't need to go anywhere else. I can go and switch here, and you can see that, that's also, trend is showing here. You can see that there's a trend showing here. There is a huge number running time. You see here there is a huge running time here showing here. These are all the running hours. You see that, from 11th of October to 16th of October, the machine was continuously operating at the maximum, and then, it went again and again. This is a trend that's showing when the machine is operating, when the machine is shut down and is not in operative, right? So any data that coming from that, it depends upon the data. The graph will show you different metrics, meaningful information to you to analyze this data and things like that. This is how you can analyze the data deeper into the Analytics Studio. And you don't need any technical knowledge to understand this. I mean, from the IoT technical knowledge, you don't need to understand that, but you need to have a mission, your mission. You should know your mission about mission, right? So the next feature is the control panel. This is a beautiful feature that you can see the live data happening here. In the control panel, typically in the manufacturing or in the operations support team, where they want to continuously monitor, they have a big displays or TV displays, panels are there. They want to continuously monitor the operation or running time of that or any equipment or conditions, right? They want to monitor it. They can use the control panel. The control panel is kind of full screen display with auto refresh. So basically, if you put it in your TV and it shows that the full screen view of your machine. So whenever the data coming in the backend, this screen automatically refresh, the data are showing. So it shows the current value of the operating environment. So you can pick and choose any data that you want to show here. It's not hard coded. It's like, you can add data. So you can just add a control panel, choose the device that you want to add. So let me take a device 2, and I want to add a total quantity. Now I added that here, right? Now you can, so you can see here total quantity is added here. So this is how I know you can keep adding n number of cards depending upon your display type and how you are showing that. But you can define whatever card you want. You don't want to show this card. Oh, I don't need this card here, right? I can remove it. You can remove that card as well. So that will automatically remove that card and bring the next value here. So you won't see that, right? So this is how it's showing the panel. So the panel is very, very useful if you want to continuously monitor. You have a support team or technical team who wants to monitor this continuously. Put it in a display. I wanted to see that always. We want to be very proactive. Then you can use this control panel screen to go through the live view of the data that's coming from your equipments deployed in the remote environment. Now, I wanted to show to my management some reports. I want to show them, hey, I'm seeing a lot of issues there in my particular mission. So I wanted to report to my management to take a look at that, or replacing that equipment or replacing some parts of the equipment. So I want to create some kind of a reports, right? That means you need to understand the data, right? So you can pick and choose the time here in the data explorer. Now you go and choose a, one one device or equipment, and you pick and choose which one you want to show to your management. I want to show them the frequency, vibration level. Okay, so you choose the vibration, and then you click on the search. So it brings that data to you and showing you in a graphical view, and also the data is coming here. You can export this as a data file, and you can send it to your management as a report. Or you wanted to compare and show to them, hey, see these two missions, there is a one mission is always troublesome, and or one particular equipment is always troublesome, right? So then you want to show the two devices or two equipments. You pick a two, and then go and select a common parameter for both of them. In this case, I want to show the utilization of the two missions. Okay, then I wanted to create a graph, and then it generates a graph. Now you see that the comparison of the two missions. So the asset 2 has a higher running rate, higher consumption rate than the asset 1. Both are running in the same time, same duration, but you see that asset 1 is taking less voltage than the asset 2. That means it's a high power consumption, energy consumption. That means it could be a problem, that mission, depending upon the mission, you can understand that, or it could be a high productivity of that mission. So anyway, it's up to us to compare it, but this kind of a data is showing you both asset and then their values. Again, you can export this data and see that. So either you want to compare two missions, or you want to understand the trend of your particular mission, and you want to report to your team, and your management they may not have access to this portal, but you still want to report to, send it to them. You can use the data explorer to export it. And the last feature, critical feature, there are a lot of other things are there, but last critical feature is the data rules. I want to trigger the alert, right? You can go and choose the device to set the alerts. I want to see the alerts. Just go and trigger, choose a device. Let's take, second as a device I have selected, and then I want to, send the alert when the build speed is greater than, let's take, 100. Okay, there's 100. Then I want to send alert. So you choose the alert type. You want to just put it as an info alert, or critical alert, warning alert. Let's take a warning alert. You want to send it as an email, or you wanted to send it as a SMS, or you wanted to send this information to your ticketing systems, like any ticketing desk, service desk ticketing systems. The API that you want to call and send it, you can configure the API here. You can put the API webhook API, and that sends a trigger the ticket to your system. So anything you can connect here, or you can do any three of the operations, or you want to send it as a mobile alert, you can send it to your mobile app as well. So you define this alert whenever the data that is reaching beyond this threshold, this solution sends alert. You don't need to go to the platform, IoT platform, to do this. You can still do it from your data analytics studio itself. So you have a better control on the data alerts and data analysis and alerting mechanisms. So this is how you have to see that. There are other way, you can create a number of, you can see the devices, you can create a number of users, you can add users and things like that. So you can add another user here, or any other mechanism. So overall, this is how you can monitor your data that connected with your equipment, and the equipment created data, and then you can see the data here in the visually in the studio part. With that, let's go back to the presentation where I wanted to talk about the last point. Okay, sorry. The conclusion is, what how we can do that, right? What is the advantage of this? Why we have to do the remote monitoring? Why it is important to do the remote monitoring? Of course, there are business challenges, but what value that we are getting out of this remote monitoring? It's not just about monitoring the device or the equipment that are in the remote place. First thing, it gives you the visibility. Monitoring is just to give you the visibility. Of course, it is good, but I want you. It also helps you to understand the trend happening. What is the right running time of your mission? Sometimes your mission is longer running missions need a quicker maintenance activities. Let's take this way as example. You have a car. Your car is running, right? And the more your car is running, it required a maintenance activity like oil change or tire rotations, right? It has to happen. So the more your car is running, the quicker you have to do that. The frequency of oil change and tire rotation is happening very frequently, right? If you are running a less hours of the car, then the frequency of the maintenance activity is longer, right? You don't need to do that quickly. It may be taking 3 months, 6 months, whatever it is, depending upon your run rate. So now, how do you know that how frequently I am changing my oil? How frequently I'm changing my tire, right? Now in the modern cars, it's indicating you, oh, you need to go and change it. But in traditionally, we don't know that. Like 10 years back in the cars, we don't have this flexibility of understanding when I have to do the maintenance. You need to mark it, you need to run it. This is how the manufacturing or in the utility companies are running today, because they are having a machinery that are 10 years older or 20 years older, running on the remote place without any history of the information. So if you start capturing this data, then it helps you to understand the running time of your mission. Then you also understand the downtime of the machine. Whenever it is down, right, whenever it is due to mechanical problem, you understand that data. So you know the running time, you know the downtime. Then you can understand the frequency of the downtime. Based on this trending data, you can understand the frequency of the downtime. If my machine is running for 10,000 hours, then my machine need a maintenance, because there is some breakage is happening always. If it is running near to the 10,000, around 10,000 timeline, so you can plan it. Oh, I'm reaching 9,000 now. It's a time for me to go and do the maintenance before even my machine is down, shut down by itself due to maintenance fault problem or faulty problems. So you can understand the downtime, and you can understand the frequency of the downtime to understand when you have to do the maintenance activity. That's a prediction, right? So you have a visibility as a basic, and you have understanding about how my machine is being utilized, and the utilization, and you get the idea about when my machine is going down, the frequency of downtime. Frequency of downtime help you to understand when the next downtime could be, and then you can go and do the predictive maintenance instead of preventive maintenance. So this is a possibility. So you start from visibility and goes all the way to the higher efficiency and improving the operations on the remote machineries. With that, hope we concluded the importance of remote monitoring at this current pandemic situation. Not only that, this trend is going to happen, so we can continuously monitor. When we have a remote for our car, why not we have a remote for our missions that are deployed in the remote place? That's the question this solution is answering here. Over to you, Abhishek.
Thank you so much, Hari. Thank you so much for the session. And so, guys, we are coming towards the end of the session. So, this would be the right time for asking the questions. Okay, I've got one question. So Hari, how can I minimize the risk of downtime with a remote monitoring solution in times of high demand or low personnel?
Yeah, sure. So the very first thing is risk of downtime, right? So risk of downtime is based on the running time of the mission, right? Every mission has a as per manufacturer would have recommended it. Every mission has a downtime. It's a default. When you say downtime, it could be a planned downtime, or it could be a the faulty downtime, right? The idea here is to stop the faulty downtime, unplanned downtime, right? Unplanned faulty conditions, and going and fixing that remote mission is expensive. Not only that expensive, but it is also costing the business. So the idea is to stop the prevent the failure in the missionaries. To prevent the failure, we need to understand how long the mission is running, right? So the runtime is very, very important to avoid the downtime risk. If we know the trend of runtime as comparing to the manufacturing spec, as well as the trend happening in the remote condition, environment condition, the weather condition, the other condition, other local condition that might cause a problem. So we need to understand not only the mission runtime, but we also understand the environment condition of that location to predict, what is the next downtime. So and then preventing that. So understanding the runtime, understanding the frequency of the downtime is helping us to understand, avoid the risk of failure there. And that's how we need to start doing that. It's as we talked about the same way, right? So we need to start capturing first the runtime, and then understand whenever the planned is downtime, which is more like a preventive maintenance, which obviously many of the equipments we are doing today as a preventive measure. But the goal is to go to the predictive. So goal is to go to the predictive to understand when the machine can go down. Before it goes down, I wanted to go there and fix it, right? By understanding the vibration of the data or kind of operational data. So not only the runtime, but also the understanding the performance of the mission or operating condition of the mission is important to understand the downtime risk and preventing that risk.
Okay, thank you so much, Hari. And we have one more question. Can one system monitor several sensors input around the clock?
Yes. So usually, the sensors can be multiple. If you have industry grade sensor devices, IoT gateways are devices that you deployed in the attached with your machine, which is communicating to the cloud or any of your IoT platform wirelessly. You can have multiple sensors. These sensors can be connected to one particular device and send it. You probably need a sensor hub to collect the data, or it may be equipped with your device itself, the IoT device itself, which can collect all the data at once and then sending us a consolidated data to your data logger or cloud data storage environment. So either case, you can definitely connect multiple sensors to one gateway, but it's purely depending upon the type of IoT gateway that you are employing. There are low cost IoT gateways or modem. There are high cost gateways. So it depends upon what you are picking and choosing. That's where the hardware selection is very, very critical, and that's one of the biggest challenge that many of the industrial companies are facing, because they are not they have to pick and choose the hardware, IoT hardware. There are plenty of options available. So to help our customers, we provide the hardware also, and we have industry grade. We have a partner who deliver us the industry grade IoT devices, modem, as well as gateway routers. And depending upon the use case, depending upon the number of sensor that we have to measure, we recommend the customer to use the right tool. And we also configure that along with the Fogwing. So when we deliver this to customer need not think about device configuration, IoT device configuration. So they just need to plug in or fix the sensors in a specific condition and start sending the data to the cloud, and they can start seeing the data itself in the analytics studio. That's how we provide end-to-end solution to our customer to simplify the IoT implementation further.
Thank you so much, Hari. So, guys, any more questions? I think there are no more questions. So, I think we can wind up, Hari.
Yeah, sure.
Okay, thank you so much once again for joining the webinar. And we will be having a recorded version of this webinar in the YouTube channel. You can visit our YouTube channel and you can watch this video for your reference. Thank you so much for connecting, and see you next month. Thank you. Have a great day.
Thank you all. Have a great day.